Hi, my name is Heini Ahtiainen. In this presentation, I'll give you important information on the effectiveness of measures and pressure-state linkages surveys to help you fill out the surveys. Expert surveys for the sufficiency of measures analysis to support the HELCOM Baltic Sea Action Plan update. In this presentation, I will describe the contents of the expert surveys on the effectiveness of measures in reducing pressures and pressure-state linkages, and give instructions on filling in the surveys. The methods and surveys have been developed by the HELCOM Action Project with the support of the HELCOM platform on sufficiency of measures. First, some background. The sufficiency of measures analysis provides information on the improvements that we can achieve in environmental components and human pressures with existing measures in the time frame of the analysis. It also enables us to assess whether we can achieve good environmental status with existing measures. There are 3 expert surveys to support the sufficiency of measures analysis. First, on activity pressure linkages, the second on effectiveness of measures in reducing pressures, and the third one on pressure-state linkages, meaning how pressure reductions affect environmental state. Activity pressure surveys have been completed for most of the topics, but some of you will also receive these Excel-based surveys together with the other 2. The other 2 surveys on the effectiveness of measures and pressure-state linkages are the primary focus of this presentation, and they are implemented using an online survey platform. The same general approach is applied across all topics to ensure comparability and coherence of the analysis. By topic here, we mean pressures and state components, which are the same as in the second holistic assessment of ecosystem health, HOLAS 2. Various topics are included in the analysis to cover broadly the state components and pressures in the Baltic Sea. Each topic survey is designed to include as much topic-specific information as possible while maintaining comparability across topics. The components of the sufficiency of measures analysis are shown in this diagram. The aim of the analysis is to predict the environmental state at a future year, the blue box, taking into consideration the effect of existing measures and possible development of human activities that takes place in that time frame, and how these 2 factors affect activities and pressures, and finally, environmental state. Existing measures are those that have been implemented, are being implemented, or are planned to be implemented in the time frame of the analysis. The focus of the expert surveys is shown here. The green one shows the activity pressure survey, the red one the effectiveness of measures survey, and the yellow one the pressure state survey. In this presentation, we focus on the effectiveness of measures survey in red and pressure state survey in yellow. To know how measures affect environmental state, we need to know how measures reduce pressures and how this reduction in pressures affects environmental state. Let's first look at the effectiveness of measures survey. The aim of the survey is to assess the reduction in specific pressures from specific activities from implementing generalized measures, so-called measure types. The reduction in pressures is assessed as a % change. The assessment is based on the expert elicitation in the survey, but the expert responses will be complemented using data on effectiveness of measures from literature and models. Thus, both expert opinions and existing literature are used to assess the effectiveness of measures. The effectiveness of measures survey includes two main question types. This slide shows an example of the first question type. The example is related to benthic habitats, loss of seabed. In the first question type, you are asked to assess the relative effectiveness of measure types and certainty of the effectiveness. Note that we are talking about measure types instead of individual measures. Measure types are more general than individual measures, and they can include several individual measures. Measure types are used to reduce the number of measures and make the analysis feasible. This question type is implemented as a grid question, where you assess the effectiveness of the measure type and the certainty of that effectiveness simultaneously. When you assess the effectiveness of the measure types, only consider factors that affect the effectiveness after implementation of the measure. Assume that the measure is fully implemented and there are no time lags. Consider the ecological effectiveness of the measure, possible legal considerations, and enforcement issues that may affect the effectiveness of the measure type after its implementation. In the grid question, place the measure type with the highest effectiveness on the far right. If the measure has no effect on reducing pressures, place it to the far left. When you assess the certainty of the effectiveness, take into consideration the level of scientific evidence on the effectiveness of the measure, possible geographic variation in the effectiveness, and grouping of individual measures under one measure type. Do not consider your personal certainty here. There are separate questions which allow you to express your own personal certainty in your responses. The second question type in the effectiveness of measures survey asks you to assess the percent effectiveness of the most effective measure type in reducing the pressure in percentages. The percent effectiveness of the other measure types can be assessed based on your responses to the relative effectiveness in the previous grid question. This slide lists issues you should pay attention to when answering the effectiveness of measures survey. Assess effectiveness as an average over the entire Baltic Sea. Only consider areas where measures would be relevant or they would have an effect on pressures. Base your assessment on the current situation, as we are talking about existing measures. Note that the effectiveness of measures is assessed separately from the activity pressure linkages and the pressure state linkages. There are separate surveys to assess how activities contribute to pressures and how pressure reductions affect environmental state. This effectiveness of measures survey only assesses the change in pressures from implementing the measure types. There is no consideration of the state components here. In the grid question, remember to place the measure type with the highest effect to the far right. Measure types that you assess have no effect on reducing pressures, place them to the far left. And remember to take note of the factors you should consider when assessing the effectiveness of the measures and the certainty. They are listed in the instructions of the grid question. Let's look at the pressure state survey next. The aim of the survey is to assess the contribution of pressures to state components. This is done by first asking you to select the most significant pressures affecting the state component. And second, asking you to assess the pressure reductions required to achieve state improvements in a specific state component. The exact formulation of the pressure reduction question depends on the existence of a threshold for good environmental status. If GES threshold exists, the question asks you to assess the required pressure reduction in percentages to achieve or maintain good environmental status. If GES threshold does not exist, you are asked to assess the required pressure reduction in order to achieve specific state improvements. The pressure state survey also includes questions on time lags between measures and state. The assessment of the pressure state linkages is mainly based on the expert responses given in this survey. If existing data and literature are available to assess the pressure state linkages, it can be used to complement the expert responses. Let's go over the pressure state survey. We'll continue with the example on benthic habitats. In the beginning of the pressure state survey, you're often asked to select the state components for which you will assess the pressure state linkages. These state components can be, for example, species, substances, or communities, as in the case of benthic habitats. It's also possible that this question is followed up by the possibility to choose the geographic areas for which you will provide your responses to. The first question type in the pressure state survey asks you to select the most significant pressures to the state component and assess their significance. You can select from 3 to 6 most significant pressures. When you assess the significance of the pressures to the state component, think of it as an overall significance, which captures, for example, the extent, area, and duration of the pressure. After you have selected the most significant pressures affecting the state component, you are asked to assess how much all of these pressures need to be reduced to achieve or maintain good environmental status for that specific state component. Or, if there is no GES threshold, how large state improvements could be achieved with specific reductions in all the pressures that you selected on the previous page. Note that in these questions, you should consider all the pressures you selected on the previous page and that they are all reduced by the same amount. Note also the infinite time frame in the question, regardless of the time it takes to achieve these pressure reductions. Here we are asking for minimum, maximum, and most likely pressure reductions required to capture possible uncertainty about the required pressure reduction to achieve state improvements. This slide lists issues you should pay attention to when you're answering the pressure state survey. As explained, in the beginning you may need to choose the state components and the geographic area for which you want to provide responses to. Note the geographic area in the questions, because it varies across topics, but it may vary also within topics. For example, across state components or species for biodiversity topics. As explained before, the questions assume that the time frame is infinite. The pressure state survey, however, includes separate questions on time lags between measures and environmental state. Base your assessment on current pressures. When assessing the significance of the pressures to the state component, think of it as an overall significance. Minimum, maximum, and most likely pressure reductions are asked to capture uncertainty in the pressure reductions required, for example, to achieve good environmental status. Note that there is no pressure state survey for some of the topics, for example, noise and litter, only the effectiveness of measures survey. Then some practical instructions for answering both of the surveys. Group responses are possible, so several individuals can answer the survey using the same link. But it's important to record the background information of each respondent. There are questions about the background of the respondents at the end of the survey. You can save your responses and continue answering later. It's possible to skip questions or parts of questions if you are not familiar with a certain topic, but we would like to encourage you to give your expert opinion on as many questions as possible. All survey sections in both of the surveys include assessment of your personal confidence in the responses you have provided. Note that the progress bar included in the survey is based on the total number of survey pages, and it's not dynamic. So if you don't select all the possible topics to answer to, the progress bar does not take this into consideration. Therefore, it should only be used as general guidance. The survey responses will be used in the sufficiency of measures analysis to create probability distributions to project future environmental conditions based on existing measures. The expert responses will be complemented with data from literature whenever available. The assessment of sufficiency of measures is done at the Baltic Sea scale, but the model generates also sub-basin specific results. When we are presenting and interpreting the results, we will include assessment of the uncertainty and limitations of the model.